You are looking at our Electron rocket, ready on the launch pad as we begin the countdown to liftoff in a little over 15 minutes for today's mission. We love the nightlife for Capella Space. Hello and welcome to the live broadcast of our 40th Electron launch, scheduled for liftoff at 11:45 a.m. local time or 11:45 UTC. The sun is trying to shine. It's doing its best over Pad B at Rocket Lab Launch Complex 1 in Mahia, our orbital launch site in New Zealand, and we are counting down to today's launch in just 18 minutes from now. My name is Muriel Baker.
And I'm Likita Satharsala. And we're back in mission control for today's dedicated launch for Capella Space, after having stood down from the first attempt a couple of weeks ago due to an engine sensor reading. In the final moments before launch, one of the Rutherford engine sensors picked up on low igniter pressure, which meant the rocket flagged it as no-go for launch, and there was an automatic safe abort. Now we're back on the pad and ready for next attempt.
And not only have we returned to the pad, but we are back with an exciting new twist. Congratulations to those of you paying attention to the rocket in our opening shot and who have figured it out already, because we all know by now that for Rocket Lab, red means recovery. And so with a new red booster on the pad, today's launch is also a recovery mission, or a splash and grab, as we'll probably call one of our future recovery launches. So why the switch to recovery? Well, Electron's rolling off our factory floor every 3 weeks or so now, and we had a recovery booster fresh off the production line and ready to go in the days before our first launch attempt. The call was made to bring forward that recovery booster and swap the payload onto this Electron to tighten the turnaround to get back to the pad for Capella and accelerate our efforts to make Electron a reusable rocket at the exact same time.
There's even more exciting recovery news to this launch, because today, for the first time in Electron's history, we're launching with the Rutherford engine that we've already flown before. This recycled 3D printed engine was part of the power pack that flew the There and Back Again recovery mission we launched in May last year. After bringing this stage and its engines back from the ocean, we refurbished one of those engines for a full requalification campaign. That meant taking it through all of the same acceptance tests we performed for our brand new engines, including multiple full mission duration hot fires. The results were impressive, with the engine hitting all of its marks and performing at the same level as the newly built ones. So it was given the green light by our propulsion team for reflight.
We will be attempting to bring back this engine again, along with the first stage, once it makes its way back to Earth from space underneath a parachute today. Our marine recovery team are in place, and you can see the feed from the boat right there on your screen, and they are waiting for the call to move in for collection once it splashes down. This recovery mission will be our 8th booster recovery attempt and one of the team's final tests before we attempt to refly not just one engine, but an entire previously flown Stage 1 on a mission in the coming months. So today is a hugely exciting mission and a big step towards reusable Electron rockets.
The primary mission for today, though, is of course to deliver a satellite to low Earth orbit for Capella Space. The payload onboard Electron is a single Acadia satellite that will join Capella's constellation on orbit, producing synthetic aperture radar imagery, otherwise called SAR. SAR is a form of radar that creates images by bouncing radio signals off the Earth's surface and measuring the amount of signal that echoes back, creating images based on strength and time delay of the return signal.
The great capability of SAR is that Capella satellites are able to create images in all weather conditions and whether it is day or night, delivering on-demand data when and where it is needed from. Today's launch of the first next-generation Acadia satellite by Capella will mean even faster downlink speeds and higher quality images for Capella's data users. Here is more from Capella.
To reiterate, the goal of this pass is to establish contact and assess spacecraft health. Command, do you have any questions? Let's rock and roll.
We learn really fast, and we build satellites here in San Francisco. We learn things quickly, we go back in the factory, and we make changes, and we go back to the launch site and launch new satellites. If there's one team and one company in the world that could do this, it's this team and it's this company, it's Capella. And that's why we're the first and only American company that's ever been able to do this. I mean, we were the first American company to put a commercial SAR satellite. We're the highest resolution SAR imagery in the world in the most compact form. We're the first one that's able to do real-time tasking, which means people are going to be able to get their imagery as quickly as it's possible. So it's not just that we've done something as complex as putting a satellite up, we've put up the best satellite in space. And we've done that with just 100 or so people in a very short amount of time.
We Love the Nightlife is our third dedicated Electron launch for Capella and the first of a new 4-launch deal that will see Capella back on the pad with Electron multiple times this year. Those missions, much like today's launch, will deploy a single Acadia satellite to a 640-kilometre mid-inclination orbit from LC-1, helping to expand Capella's constellation and provide more rapid revisits across diverse regions on Earth.
Checking in on the clock, we're approaching T-minus 12 minutes and 48 seconds, so it's time to listen into the Go, No-Go poll by today's launch director, Joseph Carpico. The LD will check and confirm with each station that the respective systems are go for launch. Let's listen in.
This is the LD on mission with the Go, No-Go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
Recovery.
Recovery is go.
LD sub.
LD sub is go.
That concludes the Go, No-Go sequence. We are T-minus 11 minutes, 20 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
And with that, Mission Control confirms that we'll be proceeding with the rest of today's countdown and moving forward to liftoff in around 11 minutes.
As we count down to liftoff, let's take a closer look at our Electron rocket. Electron is a 3-stage launch vehicle capable of lifting 320 kilograms or 705 pounds to low Earth orbit. It's made from carbon composite and stands 18 meters or 59 feet tall, and when it is fully fueled, weighs in at around 13,000 kilograms or 28,500 pounds. The hardest work for Electron is in the first few minutes of launch, when the 9 engines at the bottom of stage 1 that you can see there takes us through the dense atmosphere of Earth with 224 kilonewtons of thrust. Those engines are the Rutherford, our world-first 3D printed electric pump-fed engines. At around 70 kilometers altitude, roughly 2.5 minutes into flight, we jettison the first stage, and the vacuum-optimized Rutherford engine on the second stage will light up and take us the rest of the way to orbit.
Now, once we get to orbit, around 9 minutes into flight, our second stage separates from our third stage, which we call the kick stage. The kick stage takes the payload from an initial elliptical orbit to a circular orbit ahead of deployment, using a small but highly capable 3D printed engine called Curie. We're just 10 minutes away now from our 40th liftoff. It feels like just yesterday Electron lifted off the pad for the very first time. A lot has changed since then, with the commissioning of our second pad here at LC-1, dedicated pad on the eastern shore of the US with LC-2, missions to the moon, bigger rockets, the list goes on. So as we look to the sky for the 40th time, let's take a look back at the last 39.
I can't believe we're at Flight 40. Honestly, it feels like Flight 1 was just a few weeks ago. And I just want to take this moment to congratulate the whole team for getting us to this point. and also all of our customers who have entrusted us to fly their precious payloads. We've done some amazing missions from little CubeSats to all the way to the moon, and it's a great privilege to be here today. So as we fly out here at 40, can't wait for 80 and beyond.
Along with our 40th launch today, this year has been an incredibly busy one for Electron and our team. Our rocket has taken flight 7 times across our 2 launch sites, with our most recent launch just a couple of weeks ago, and one that also happened to include our latest efforts at rocket reusability. So with today's recovery mission back-to-back with our recovery launch just a few weeks ago, let's take you through what today's recovery operations will include.
Electron is one of the world's most innovative rockets. Since its first launch in 2017, it's pushed the boundaries with 3D printed engines, electric turbopumps, and new carbon composite technology to become one of the most reliable and frequently launched rockets every year. And what's faster than building more rockets? Reusing the ones you already have. Which is why we're evolving Electron into the world's first reusable small orbital rocket, so we can launch, splash down, and launch again. Here's how we'll do it. First, Electron lifts off from the pad with 9 Rutherford engines on Electron's first stage, propelling the rocket toward space. Around 2.5 minutes after liftoff, at around 70 kilometers above Earth, the 9 Rutherford engines on Electron's first stage shut down, allowing the rocket's first and second stages to separate. Tiny reaction control thrusters reorient the stage to the correct angle of attack to slice through Earth's dense atmosphere as it descends. The 12-meter-long stage falls to Earth at top speeds of more than 8,000 kilometers per hour and a temperature peak of close to 2,400 degrees Celsius. About 5 minutes after stage separation, as the stage returns to Earth, a drogue parachute is released at around 13 kilometers altitude to help slow the rocket down. Less than a minute later, the larger main parachute is deployed from the first stage, bringing Electron's speed down from thousands of kilometers an hour to less than 40 kilometers an hour. Meanwhile, our recovery vessel waits patiently outside the splashdown zone in the ocean, several hundred kilometers from the launch site, and awaits confirmation of splashdown by telemetry. Once the captain receives confirmation, the chase is on. The recovery team speeds to the booster's location at sea, typically rendezvousing with it just minutes after splashdown. Using a specially designed marine retrieval apparatus, Electron's first stage is plucked from the ocean and secured on the vessel for the return trip home to our production complex to undergo testing and refurbishment for reflight.
From launching rockets to marine recovery, or even building and launching a spacecraft to the moon, we have come a long way. If anything you've seen from us excites you, and you're wondering how you can be a part of this, we have around 100 open roles right now across our launch and space systems businesses. So visit the careers section of our website and apply today.
We are getting close now to the launch handover to Electron at T-minus 2 minutes. That is when Electron's flight computer will take over the count and the rocket will switch to internal power. The Autonomous Flight Termination System, or AFTS, will also be enabled at the same time. Then, under a minute to liftoff, the propellant tanks will be at their optimum pressure levels for launch. Ground control in the Range Control Centre will confirm that the water deluge system on the pad is ready to be activated for when Electron's engines ignite.
The launch director will perform the T-minus 10-second countdown, and at T-minus 3 seconds, the engines will ignite ahead of the launch pad's hold-down mechanisms releasing at T0. We'll hand you over now to Mission Control for the remainder of the count and check back in with you shortly after liftoff.
This is the LD on mission. From now on, there should be no red flags on your critical LCCs. VCON LD on mission.
LD VCON.
Lock the auto sequence and confirm.
Confirmed locked.
And VCON confirm all expected primary flight computer ASGOs are green.
Confirmed ASGOs are green.
All operators, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Avionics batteries have switched to internal power. Ground power disabled. The vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff.
Safety launch pad.
Beginning pitch over.
Electron is up and away from the pad at Launch Complex 1, soaring through the sky and on its way to space for Capella. All is looking nominal with the rocket and its engines as the mission approaches its first notable event, max Q, or maximum aerodynamic pressure, the most intense pressure during flight that the rocket will experience. The call that we've cleared that milestone should be coming from Mission Control
HVB
shortly.
battery discharge is nominal.
Vehicle is supersonic. And vehicle has passed max Q.
There we go. That's max Q cleared as Electron continues with Capella's satellite on its orbital journey. The mission is moving along at 2,300 kilometers an hour and is now past 19 kilometers in altitude.
The next mission milestone will be the shutdown of those 9 Rutherford engines on the first stage, just ahead of the second stage separating to fire up its own
Stage
engine
1 guidance is nominal.
and continue that mission. That will be called out as MECO, or main engine cutoff,
AOS Chatham Station.
followed by stage separation, then stage 2 ignition.
Those call-outs from Mission Control should be happening shortly, so let's listen in.
Stage 1 propulsion holding nominal. Stand by for MECO in roughly 30 seconds.
Entered Bernard detect mode.
MECO confirmed.
Stage separation successful.
Stage 2 ignition confirmed.
That is MECO, stage separation, and second stage ignition all confirmed from Mission Control, and by what you saw from Electron's vehicle cameras. We pulled up the video feed from the camera on the first stage as it begins to make its way back to the Earth. Meanwhile, the fairing on the second stage should split and fall away shortly. We should hear that call across the net soon.
Fairing jettison succeeded.
You saw it there on your screen. Electron's fairing has
Stage 2
split apart
propulsion
and
nominal.
fallen away as planned. Capella's Acadia satellite is
Stage
now
2
exposed to
guidance
space
nominal.
from atop Electron's kick stage and ready for payload deployment within the hour.
HVB battery discharge is
Electron's
nominal.
second stage is moving along now at more than 8,400 kilometers an hour and at an altitude of over 130 kilometers. Meanwhile, that red booster is on its return trajectory. You can see it up on your screen to the left, with the second stage cruising along on your right. When the stages separated, the booster carried on in an upward arc from the momentum. But what goes up must come down, and with a bit of redirection from its external thrusters, which you can see happening right now, that will position the rocket stage on the right angle to come back through Earth's atmosphere. And with that, Electron will be coming home.
With 4 minutes into the mission, an Electron
Starting to
is
throttle
well on
down.
its way to orbit after lifting off from Pad B at Launch Complex 1 right here in New Zealand. The Acadia satellite for Capella Space is sitting comfortably on top of Stage 2 as it moves along at more than 9,900 kilometers an hour. Electron is headed to a 640 kilometer circular Earth orbit today, so we've still got a bit further to go to reach the apogee at second stage separation around 9 minutes post
Stage 1
liftoff.
has reached apogee.
For the first stage coming back to Earth, you might have just heard on the nets there that Stage 1 has reached its apogee, which is the highest point of its trajectory arc. That will mean it's starting to descend now, dropping in
Stage 1
altitude
re-entry reorientation
as it
complete.
will speed up with the force of gravity. It will travel this way for a few minutes before its drogue and main parachutes are deployed to help slow it down. Before that, though, as part of the primary mission, we will reach battery hot swap on the second stage. That's expected to take place at around 6 minutes into the mission.
We're coming up now to battery hot swap on the second stage. This is an action that you'll see used only on Electron. That is a swap of batteries that are powering our electric pump-fed Rutherford engine on stage 2.
Guidance still nominal,
Electron will
about
switch
200
to a
seconds
fresh
remaining.
new battery pack, and we might even see a
HVB
glimpse of the
battery
old
discharge
pair
holding nominal,
as they fall away.
approaching hot swap in roughly 30
They're the
seconds.
shiny object you can see next to the engine, so once those drop away, you'll know the battery hot swap has been completed.
Recovery vessel acquisition of stage 1 signal.
Hot swap successful.
Battery jettison confirmed.
You heard it there from Mission Control. Electron's second stage has completed its battery swap and is continuing along nominally. The launch vehicle is exceeding speeds of more than
Stage two
15,000
propulsion
kilometers an
holding
hour and an altitude of 205 kilometers, while on its way now to the mission's target orbit of 640 kilometers.
Stage 1 drogue deployed.
AFTS has safed.
That was great news from Mission Control, and while it looks like we've lost the video feed from stage 1 as we
HVB
expected,
battery
we
discharge
did
holding
get
nominal.
that confirmation from Mission Control that the stage's drogue
And stage
parachute
2
has been
propulsion holding
deployed.
nominal.
That is excellent news, just ahead of the main parachute, which should deploy in the next few seconds.
Stage 1 is subsonic. Stage 1 main chute deploy.
There's the call we were waiting on, confirmation from our team in Mission Control that the booster's main parachute has been deployed. That will mean the first stage has well slowed down its pace and should
Stage
be
2 guidance
floating.
in terminal, 25 seconds remaining.
That stage should now be floating gently towards the water
Stage
out
1
over the
main is
Pacific
disreef.
Ocean, where our recovery teams are in position and waiting patiently for that chance to move in. So just a few seconds away from the second stage's final actions. We've got second engine cutoff or SECO before the kick stage separates for its phasing orbit of Earth. Let's listen out for those milestones.
SECO confirmed.
Great news there from Mission Control.
3
With that
separation
second
confirmed.
stage engine cold and the kick stage cleanly separated, all we have left now to complete the mission is payload
Nominal
deployment
transfer
for
orbit
Capella's
achieved.
Acadia satellite. The kick stage will now move into a coast phase with its payload atop. After that phasing orbit is complete, the Curie engine on the kick stage will light up to correct its trajectory to a circular orbit before deploying the payload, which should be coming up in the next 45 minutes or so.
That booster is continuing to make its way down to the ocean as planned. At sea, our recovery crew
Before we break through, though, the latest on recovery is that the booster continues to make its way down to the ocean as planned. At sea, our recovery crew are on standby in the recovery zone waiting for that splashdown before they move in to collect the first stage. Once it has water landed, the crew will move in to pull it up and out of the ocean and onboard the recovery vessel before they
LOS
begin the
Chatham Station.
journey back to land. We will take a bit of a break now, but we'll come back to you in a few minutes with confirmation of booster splashdown. We'll be back shortly.
Stage 1 recovery vessel has visual on shoot.
To all operators, expected AOS for kick stage at approximately T plus 43 minutes 54 seconds.
Stage 1 splashdown.
Hello again from Rocket Lab Mission Control. We are cutting into this break before payload to deployment to confirm what we have just heard over the nets, that Electron's booster has splashed down in the ocean as planned. The Electron recovery operations will now move into stage collection from the water, with the crew, as you can see there, moving quickly to reach that stage and pull it on up. We'll have this video footage up for as long as we can, and if we're lucky, we might even see it pull up alongside Electron. But until we do, we will turn you back to this animated holding graphic that shows the position of Electron's third stage above us as it makes its way to its mark for payload deployment at around T plus 57 minutes. We'll see you back here then.
Hello and welcome back to the webcast of our 40th Electron mission, We Love the Nightlife, a dedicated launch for Capella Space to low Earth orbit. If you've just joined us, we've had a picture-perfect launch so far for Capella's Earth Imaging SAR mission, and pretty smooth operations for Electron recovery. Electron cleared the pad at Launch Complex 1 at 11:45 a.m. local time and soared cleanly through its first launch milestones. That's max Q, MECO, state separation, and second stage ignition before T+3 minutes. Shortly after that, the rocket completed a successful battery hot swap for its Stage 2 engine before the Rutherford shut down as planned for kick-stage separation at the mission's target apogee of 640 kilometers above Earth.
Parallel to all of those actions, of course, was our secondary mission to bring Electron's first stage back to Earth and collect it from the ocean for our 8th booster recovery mission. With clean separation of the first stage from the second after MECO, the booster completed its upward arc before making its way back down toward Earth with a little positioning help from its reaction control system. The first stage sliced through Earth's atmosphere and hit peak speeds of 8 times the speed of sound before its drogue and main parachutes deployed to safely slow down that velocity. Electron reached the ocean as planned, and our team are deep in recovery mode to pull the booster out of the water and onboard their boat so they can start the desalting process and preserve Electron for the journey back to the factory. A fantastic effort by the team made all the more impressive by the fact that today's mission flew with a reflown engine from a previous launch for the very first time. It will be so interesting to see how that engine survived its second launch and second swim in the ocean, and I have no doubt that our engineering teams are itching to dig into the data and check it out for themselves when it returns home with the rest of the stage.
Right now, though, we're just seconds away from Curie engine shutoff on Electron's kick stage carrying Capella's Acadia payload. We should be hearing the call that the Curie engine has shut off and then expect payload deployment very shortly after. So let's listen in.
Curie Stage 3 propulsion is still holding nominal. Stage 3 shutdown.
A nominal engine shutdown there from Curie, the kick stage is now in a prime position to release the Acadia satellite onto its low Earth orbit trajectory. Any moment now.
And confirmed payload deployment.
That was Mission Control on the nets. You might have heard there with the good news that we have successfully deployed Capella's Acadia satellite to its new home in space. Congratulations to the Capella team and all the best with commissioning your new satellite into service.
8 launches so far this year, 40 overall, and another booster on its way back to the factory. A huge congratulations to the entire Rocket Lab family around the globe, only 10 away from half a century.
LOS Spain.
We're looking forward to bring back on the pad again soon, including more upcoming missions for Capella Space. If you're looking to launch your career into space, make sure you check out our open roles on our careers page at rocketlabusa.com. And don't forget, you can stay up to date with all things Rocket Lab by following us on social media.
We are going to finish up the broadcast now, but let's check out today's liftoff one more time. This is Rocket Lab Mission Control signing off.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff.
We've connected the pad. Safety launch
pad.
Beginning pitch over.